No.
Okay, live YouTube is displayed.
Loading. Just a minute, sir. It will be online.
It is displayed live YouTube already on my screen.
Webinar is now
Yes,
live on YouTube.
it is all right.
Yeah.
Thank you. Madam, thank you, Hansika, madam.
Okay, sir. Okay, I'll leave the meeting, sir.
You
I'll
can
change you as host again.
Yeah, thank you.
Okay, sir.
Happy Pongal, madam. Thank you.
Yeah,
Thank
it is
you.
perfect.
Yeah, we can start, sir.
Yeah.
Yeah, very good morning to all the participants and panelists. So today, and welcome for the second lecture of this 16-week lecture series. So now I request Professor Someshwar Das, Secretary, South Asian Meteorological Association, to welcome the panelists as well as the participants. Over to you, sir.
Thank you, Dr. Lakshmi Kumar. Good afternoon. AVM Dr. Ajit Tyagi, sir, President of SAMA. Dr. Mohapatra, Director General of Meteorology, India Meteorological Department, and also today's speaker. Professor Bhaskar Rao, member of the advisory panel of this lecture series. Well, our other institutional partners are not here, but they are from SAMA-SRM, LIMES, and CMOD. Distinguished participants from 41 countries, I hope, and all the 41 countries participants are here. Ladies and gentlemen, okay, we welcome you on behalf of the South Asian Meteorological Association and SRM Institute of Science and Technology, Chennai, India. We'd also like to wish you a very happy Makar Sankranti. This is one of the very important festivals which is celebrated in different forms all over India. Actually, this is the first day of the transit of sun in the zodiac of Capricorn, and so it is celebrated all over India as a Makar Sankranti. As you know, this is the second lecture on capacity building of people in the field of atmospheric, weather, and climate sciences by SAMA and SRM-IST. As you know, we have a distinguished panel of very senior professors and scientists from reputed institutions of this region who are experts in the fields. They will deliver lectures on the fundamentals of the subject. The lecture series is targeted to the postgraduate students and professionals of non-meteorological background who are interested in learning the subject of weather and climate sciences for research and operations. It consists of 4 orientation lectures and 12 lectures on atmospheric physics. First lecture was delivered by Professor U.C. Mohanty of Indian Institute of Technology, Bhubaneswar, on fundamentals of weather and climate sciences last week on 7th of January. The lecture series will continue for 4 months. Certificates will be given to the participants who have registered for the course and will complete the entire course with at least 75% attendance and successful performance in an evaluation test which will be conducted at the end of the course. The lectures are live streamed on the YouTube channel of SAMA. They will also be available afterwards on YouTube for those who could not attend the course live. We shall try to have more interactions between the speaker and the participants in this lecture series. Please write your questions in the chat box. Our moderators will pick up the questions at the end of the lecture and they will be answered by the speaker. So enjoy the lectures and wish you all the best. Thank you.
Thank you, Professor Someshwar Das. Now I request Professor AVM Ajit Tyagi, President, South Asian Meteorological Association, to speak a few words on the relevance of the present day lecture. Over to you, sir.
Thank you, Lakshmi, and I join Professor Someshwar Das in welcoming you and conveying the greetings on day of Makar Sankranti, Pongal, Bihu, which is celebrated in South Asia widely. This is very important day, both from the season point of view, also culturally and also socially, and also have got economic relevance, which is directly related to the services part of it. This is a day when sun starts moving northwards. It comes in astronomically in the zodiac sign of Capricorn, and days start becoming longer, winter season starts receding, and people are joyous with the harvest festival. So this is the linkages of this in South Asia particularly, and I am sure in other parts of the world also, this change must be getting manifested in a very particular and important way. Now, coming to the lecture series, I'm happy that we had a very good beginning with the first lecture on the weather and climate sciences, and equally important is today's lecture, because weather and climate services have now assumed a great importance. It was always there, but now it is linked to the very existence of the humanity now. We have a direct impact on 30 odd sectors of the economy and the society, which is affected by weather and climate. And with the impact of climate change, it is going to become much more severe, and we need, I think everybody now is talking about it, and the scientists are equally working on to give a better estimates of the future climate. So coming to the climate services provided by the weather services, we are lucky to have Director General of India Department, Dr. Mohapatra, to deliver this lecture. He is a busy person as usual, but on account of the IMED's 148th Foundation Day tomorrow, his preoccupation was well understood. He has kindly agreed to deliver this lecture in person, and I'm really thankful and grateful to him. And we, on behalf of SAMA, facilitate and complement the achievements of the IMED in providing weather services, and wish them all the best in the coming years. To start with, let me tell you that Dr. Mohapatra is a cyclone man, so improvements in the cyclone forecasting. Apart from this, the weather services in the agriculture, agromet services, the water service, hydrological services, health part is assuming a great importance. Energy sector is also now closely linked with the weather products. And of course, the safety and well-being of people in the disaster risk reduction, the weather information plays a very important role. And various transportation sectors like aviation, shipping, and even the road transports gets affected by the weather. So the weather services now are highly valued, and greater demand. As we improve our services, more demand comes in. So this is another challenge which is IMED and National Weather Services are now rightfully meeting, and I'm sure in coming years with the improvement in science, climate science, and the communication and dissemination, this will improve further. So once again, I thank Dr. Mohapatra for his lecture today, despite of his busy schedule and his vast experience in heading the India Med department. I'm sure it will benefit all our young researchers and the students to see the potential of weather services and how they can contribute to it. So once again, I welcome all participants. Thank you.
Okay, thank you, sir. Ajit Tyagi, sir. Now, before we go to the lecture, I request Dr. Swagata Paira, Bit Mesra, to introduce today's speaker, Dr. M. Mohapatra. Over to you, Swagata.
Thank you, Lakshmi. I hope my screen is shared.
Yes.
Yes, yes.
Okay. So today, this is the second lecture in this online lecture series, and the topic is related to weather and climate services. Dr. Mrityunjay Mohapatra is currently the Director General of Meteorology, IMD. He is the permanent representative of India with World Meteorological Organization and elected as member of Executive Council, WMO. He headed Regional Specialized Meteorological Center for Tropical Cyclones during 2014 to 2019, prior to become DG, IMD. He has 28 years of experience in meteorology. He has made significant contribution in the improvement of cyclone warning services of IMD. That's why he is popularly known as the Cyclone Man of India, which Professor Tyagi sir also mentioned just now. Academic honors and awards, he has received a number of awards and recognitions, including honorary DSc from FM University, Odisha, honorary DSc from KIIT University, Odisha during 2020. He is fellow Indian Meteorological Society in 2019. He got the Certificate of Merit for Young Scientist Award 2008 by Ministry of Earth Sciences, 25th Biennial Mohapatra Award in 2008 and 9. Also, he got Commendation Certificate from 1989 from DRDO for contribution to Integrated Guided Missile Development Program. Apart from that, he has a lot of things like Bharat Gaurav Award in 2019 by Jai Bharat Foundation, Odisha. Felicitation by Chief Minister Shri Naveen Patnaik in 2019. SAMA-SRM also he has received in 2019 by SAMA Charitable and Education Trust, Odisha. Bhumipatra Samman he got in 2020 by the Bipal Bhai Behera Chakradhar Smriti Sangsad, Odisha. Commendation certificate from various organizations and prediction of cyclone, publication and documentary on live profile and contribution to cyclone warning service in various press and electronic media. His research interest is enormous. He has authored more than 100 research papers published in peer-reviewed national and international reputed journals. He has edited 3 books, 5 journals, and 15 international reports. He is Master of Science in Physics, and also he has done PhD in Physics. Thank you, sir, for accepting our request. So now floor is yours.
Yeah.
Swagata, please stop sharing.
Yeah, you can share.
What, Lakshmi?
No, nothing. I am just requesting to stop sharing. I think sir will has to share his presentation.
Yeah. Okay.
Whether my screen is visible?
Yes, sir.
Yes, sir.
Is it moving?
Yeah.
Yes.
Fine. So good evening, namaskar to all of you. Respected Professor Ajay Tyagi Sahab, Professor Someshwar Das, Dr. Pyara and Dr. Lakshmi, distinguished members of SAMA, dear students participating in this program, ladies and gentlemen. At the outset, I join with Professor Tyagi and Professor Das to wish you all a happy Makar Sankranti, happy Bihu, and happy Pongal. It is a festival which is well defined in terms of culture, traditions, as Professor Tyagi told, and also it is based on science. It gives a timeline about the change of seasons as accepted by our ancient people, and which is well proved by the current science understanding by all of us. I express my gratitude to SAMA for giving an opportunity to speak in this occasion and to interact with all of you about the weather and climate services, the current status in the world, and specifically in the South Asian region. So if we just think about weather and climate system, what we find that there are various spheres interacting with each other, like solid earth or lithosphere. We've got the gases, that is atmosphere surrounding the solid earth. Then we've got the hydrosphere, that is all water bodies, including the cryospheres, and also the biosphere, the lives on solid earth, the atmosphere, and also in water. But I want to say that all these spheres are not independent of each other. They interact with each other. And weather and climate, what we find today, is nothing but the byproducts of this interaction among all these. Just before the beginning of this lecture, there was a question, and Professor Das was answering about the climate drivers. I will say all these spheres are the climate drivers. The interaction among these spheres decides the climate and weather at any particular place and time. Weather and climate has no boundary. Therefore, something happening somewhere in some corner of the globe can have the impact in other corner of the globe. So if you just look at little more specifically, you will find that all these spheres interact with each other by various means. But above all, this is the sun which controls the energy distributions. The changes in solar inputs can also address the changes in the weather and climate conditions in different parts of the globe. So there is interaction between solar system with the atmosphere and earth and solid sphere, biospheres. And there are various types of interaction in terms of the radiation or radiation budget, in terms of the water vapor, or in terms of the various gas compositions in the atmosphere. There are natural changes, and natural changes lead to a natural process of climate change. The climate change was occurring earlier, climate change is occurring now, but also climate change will occur in future because of the natural variations in the interactions within these spheres, and especially between sun and the earth system. But however, in recent time, what has happened actually, because of the man-made activities, there has been certain distortion in the natural system. There has been injection of various gases which can imbalance the atmospheric compositions and hence the atmospheric balances. Certainly, there are certain gases which are very much essential, like the greenhouse gases, for which the temperature of the surface of the earth is around 15 degrees Celsius. But at the same time, if we go on increasing the enhanced greenhouse gases produced by the atmosphere, produced by the man-made processes, like say urbanizations, industrializations, increase in populations, etc., these greenhouse gases can lead to rise in temperature, which is popularly called as global warming. And this global warming can lead to different changes in the weather and climate. And most importantly, the extreme weather events which are occurring in an enhanced frequency, duration, and intensity in the recent years because of this phenomenon. So I will just limit myself. I will not going to discuss about the climate change, but I will discuss about weather and climate services. So when we say the weather and climate services, as I told you, these are the byproducts of the various interactions among the various components of the Earth system science. And we will very well appreciate that, for example, you can find out sometimes while sitting outside of your house in a summer month, that small dust particles along with the leaves, dry leaves, and straws, etc., they are just rotating in anti-clockwise direction in northern hemisphere and clockwise in southern hemisphere, and they're going off. So that is the phenomena which you can define as weather. And it may become more serious, claiming as the name as dust devils or dust storms. But if you were to add water vapor, then water vapor can also go off and you can form the clouds. And there are various types of clouds. I'm just highlighting here the cumulus clouds, which has the potential to cause weather. Then from cumulus clouds, you got the cumulonimbus clouds, which leads to the thunderstorms, hailstorms, squalls, gustiness. This is the case in the tropical environment. If you go to extratropical environment, there is a gradient of temperature, and this gradient of temperature leads to the various types of frontal weather phenomena, cold fronts and warm fronts. But however, in both the cases, we get the highs and lows, and these highs and lows are more important in the tropical behavior or tropical climate. These high pressure cells and low pressure cells help in exchanging the mass, in exchanging the energy, in exchanging the atmospheric water vapor, and hence also leading to various types of weather phenomena. While high pressures are in general associated with clear weather, low pressures are associated with adverse weather. Now, these low pressure systems includes the low pressure area, depressions, tropical storms, and tropical cyclones, which are known as hurricanes or typhoons in different parts of the globe. But if we go a little more, you will find that these informations which are getting on day-to-day basis in our immediate environment are part and parcel of a larger environment or larger circulation processes. For example, early cell circulations or Walker cell circulations. And we all know about El Nino, La Nina, Indian Ocean dipoles. So all these are part of this type of circulation features. And if you go a little more beyond Walker circulations or circulations leading to the seasonal variations, you will find that there is variation from year to year, interannual variations in weather, and also the decadal variations in weather. And finally, of course, what we talk about in everybody's sleep, that is the global warming or the climate change. So therefore, there is a large-scale spatial dimension and also large-scale temporal dimensions when you consider different types of weather and climate phenomena occurring in the globe. But however, as Tagisa was telling, there are about 30 specific areas, but I will tell there is no such area in this world which is not affected by weather and climate. If all of us remember that when you get up from the bed, at first you look at the sky, try to become a forecaster, because we believe in the proverb that weather is defined just like morning shows the day. If morning is showing the sunshine, we believe that today it will be a very good day, but certainly it is not like that. The science has proved that morning does not show the day. But however, as a common man from the ancient era, people tried to provide the weather information by themselves and provide the weather forecast, as they believed that morning shows the day. That means everybody wanted to watch, everybody wanted to monitor, and everybody wanted to predict the weather, because weather was part and parcel of every human being from the very ancient ages. And now, with the improvement in socioeconomic conditions, there has been more utilization of weather and climate information in all our socioeconomic progress. Now, this is just a nutshell. In this slide, you can find out various sectors which are affected by weather and climate services, be it monsoon, or be it aviation, or be it surface transport, or be it maritime, or be it agriculture, hydrology, power, energy, health, sports, tourism, or it is pilgrimage.
Dr.
Everywhere.
Mohapatra, your slides are not being
it is not moving.
I am not able to see. I am able to watch your. But
yeah, it is moving, sir. Now the slide title is
maybe
History of Weather and Climate Services.
Okay.
Yeah,
it is moving. It is moving.
Yes.
Maybe, sir, you can check your PC. You can switch off and again join or something like that. It may help. Are you getting, sir, now?
Yeah, it's fine. Thank you.
Okay.
Sorry for interruption.
And
okay.
In YouTube, you can get that streaming.
Yeah.
Okay. So thank you. So I'll just talk about a little history. I was telling that every human being tried to monitor and predict the weather and climate. If you look at the ancient era, you will find that 650 BC, the Babylonians tried to predict short-term weather changes based on the appearance of clouds and optical phenomena such as halos. By 300 BC, Chinese astronomers also tried to develop a calendar dividing a year into 24 festivals. And similarly, I don't know from which day Makar Sankranti has been accepted by the South Asian community. So therefore, the ancient people were also genius to study the weather and climate and hence to predict on a seasonal basis. So around 340 BC, Greek philosopher Aristotle wrote the book Meteorological, which included theories about the formation of rain, clouds, hail, wind, thunder, lightning, and hurricanes. Now, if you look at the modern day forecasting, the modern age of weather forecasting began after the electric telegraph came in 1835. The two men credited with the birth of forecasting as a science are Francis Buffett and Robert Fitzroy. Buffett developed the wind force scale and weather codes. Fitzroy's warning service for shipping was initiated in February 1861 with the use of telegraph communications. The first day weather forecasts were published in the Times in 1861. In the following year, a system was introduced for hoisting storm warning cones at the principal ports when a gale was expected. Now, if you look at the case of South Asian region, you'll find that early philosophical writings of 3000 BC era, such as Vedas and Upanishads, contain serious discussion about the process of cloud formation and rain and the seasonal cycles caused by the movement of Earth around the sun. Varahamihira's classical work, Brihad Samhita, written 500 AD, provides the clear evidence that there was a deep knowledge of atmospheric processes at that time. We have Aditya Jayati Vrishti, that is, sun generates rain, or sun creates rain. It is taken from that Brihad Samhita, and it is the emblem of India Meteorological Department. So Kautilya's Arthashastra, the Kautilya, the great Chanakya, at the time, the finance minister of the king, he could analyze the importance of rainfall, and he could contain the records of the scientific measurements of rainfall and its application to the country's revenue and relief work. And coming further, there are many poets, especially Kalidasa wrote the poem Meghdut or epic Meghdut. In Meghdut, as the name suggests, it is the ambassador of cloud. And he told that it is the wind which brings the clouds. And that also understood by the name of monsoon. Monsoon is the wind, is not the rain, but monsoon wind brings the rain. So it is written in Meghdut that the cloud propagates from south to north. Now what we say about the intra-seasonal variations, and as for the wind variations from south to north. So like that, if you just look at, there has been a lot of ancient knowledge with respect to the weather and climate. So if you just look at again the instrumental era in this region, I will tell you that we have got a long history of instrumental observations. The first meteorological observations came in Calcutta in 1785 and Madras in 1796. Asiatic Society of Bengal, founded in 1784 in Calcutta and 1804 in Mumbai, promoted scientific studies in meteorology. At that time, India means bigger South Asia. Henry Piddington published 40 papers during 1835 to 1855 in Journal of Asiatic Society on tropical storms and coined the word the cyclone. So we used a telegram at that time as and when it came up, and we adapted in this region all types of science and technical tools which could be utilized for weather monitoring and forecasting. If I just look at the various types of severe weather which affect our socioeconomic conditions, you will find that there are various types of severe weather, starting with the floods, which occurs for the days, earthquake for seconds and minutes, cyclones for the days, droughts for the months, and landslides which occurs for a few days, avalanches for a few days, heat and cold wave can occur for days and weeks, and tsunami for minutes and hours, and thunderstorm for minutes and hours. But you find that actually more 80% of the disasters occurring in the world are associated with weather and climate, or hydrometeorological in nature. And among the hydrometeorological disasters, the disaster which has caused the maximum losses and maximum deaths in the world is the tropical cyclone. I just want to give one example how these disasters, meteorological disasters, are causing losses to the economy and causing losses to the society. As per study, recent study 1970 to 2019, 33% of hydrometeorological disasters are caused by tropical cyclones. 1 out of 3 events that killed most people globally is the tropical cyclone. 7 out of 10 disasters that cause biggest economic losses in the world during this 30 years period are the tropical cyclones. It is a typical disaster which is a key interest to 85 WMO member countries. In terms of deaths due to tropical cyclones, casualties of 300,000 people in Bangladesh in 1970. That is the worst record in the history of the humankind. So what I want to say is that South Asian region is prone to very severe natural disasters, including the hydrometeorological disasters. We have got the worst record in terms of tropical cyclones. We have got the worst record in terms of lightning and thunderstorms. After East Africa, Bangladesh is this country where we have got the maximum number of lightnings. We have got the worst record in terms of hailstorms. The Moradabad, very nearby to Delhi, recorded the maximum death in the world due to a hailstorm. So therefore, we have got 3 notorious records in this region. Therefore, this region is very prone, and hence we have to work, understand the weather and climate science, and apply for the services. Now, if I just look at the various disasters, they do not occur independently. They occur simultaneously, or you can say that a multi-hazard scenario is generated when the various types of natural hazards occur simultaneously. And tropical cyclone, for example, is a multi-hazard scenario where you have got tropical cyclones, rain, wind, and storm surges, and hence it causes loss of lives and properties. On left-hand side diagram here, I will say that it is a tropical cyclone which was crossing Indian coast. I want to show you a diagram just on the top in this position. You can just see that a person is trying to construct a house, and that person is from Myanmar. And I visited in 2009 Myanmar after the devastating cyclone Nargis, when 140,000 people died in that country. So while finding out the reasons for these deaths, we found that it is not the early warning alone. Along with the early warning, you should have preparedness, planning, mitigation approaches so that you can minimize the loss of life and property. And this person who is reconstructing his house, he has lost everyone in his family. There is no kith and kin, but still he is reconstructing his house. So this point touched to me, and he brought this figure. And what does it mean to us? It means that everyone in this universe wants to live. And this is the duty of these meteorological scientists or hydrological scientists, the disaster managers, students, and all stakeholders working in this field to ensure the life to each and every human being. So this is just an example how these natural disasters related to weather and climate can cause an immense loss of lives and properties. This is just an example of Odisha super cyclone 99, how the people died, how the livestock died, how the loss occurs to all the sectors of the society. So if you just look at this type of natural disasters, it is not limited to tropical cyclones only. As I told you, there are various types of natural disasters. There could be low pressure area causing rainfall, there could be depressions, there could be cyclones and super cyclones, etc. Also, there could be some kind of small scale weather events like severe weather systems of thunderstorms, tornadoes, hailstorms, etc. So there are some of the pictures of the hailstorms and squalls, thunderstorms, etc. mapped by the various means. But I want to say that these are also the killers of the human being. If you look at today, nowadays, the number of deaths worldwide due to tropical cyclones has decreased. It has also decreased in our South Asian region. But if you look at the number of deaths occurring due to the lightning, worldwide, it is increasing. So therefore, there are the ever-increasing challenges to meet with various types of disasters associated with hydrometeorological processes. And we have to learn more and more and understand these physical processes associated with various types of disasters and take the precautionary measures. At the same time, we think about the sustainable development goals that, as I told you, because of the climate change and various man-made processes, there is imbalance with respect to the atmospheric processes. There is a changing water cycle, and there is a changing concentration of various atmospheric gases. As a result, we have got various impacts on the various types of weather and climate informations. So therefore, there has been a lot of international and national policy guidelines and understandings so that we can have a sustainable development in the universe, so that we can ensure a better earth for our future generations. So there are 13 sustainable development goals as adopted by United Nations, and 17 development goals as adopted by United Nations. And number 13 is the climate actions, which says that we should strengthen resilient and adaptive capacity to climate-related disasters. We should integrate climate change measures into policies and plannings, build knowledge and capacity to meet climate change, implement the UN Framework Convention on Climate Change, and promote mechanisms to raise capacity for planning and management. So each and every country, therefore, tries to have the developmental activities such that our atmosphere or earth system is not affected. But however, whether there is climate change or not, there will be disasters. There has been disaster in futures, but there could be enhanced disaster in terms of frequency and intensity. So therefore, each and every country tries to have a disaster management plan, a disaster management act, a disaster management policy, or disaster management guidelines. At the same time, also every country tries to have a disaster management mechanism at the institutional level. And while we talk about the management of disasters, it basically deals with the pre-disaster actions, during disaster actions, and post-disaster actions. Actions means the preparedness, planning, prevention, and mitigation processes, so that we can reduce the risk due to the disasters. And at every step, there are certain response actions by the public, by the stakeholders, and by the disaster managers. So if you look at all these aspects of the disaster management, you will find that early warning is a major component. Without early warning, there could not be any action during the disaster, before disaster, and also post-disasters. And especially when you consider South Asia, there has been some kind of survey that the socio-economic condition of South Asia is such that we cannot change our infrastructure overnight. It needs a huge investment. But however, with minimum investment in the early warning system, we can improve our early warning, and hence we can manage the disasters. But if you look at this multi-hazard early warning system, it is a need of the hour. But unfortunately, all the countries in the world do not have the multi-hazard early warning systems. There is a survey by World Meteorological Organizations. It is found that mainly the least developing countries, the island nations, do not have the multi-hazard early warning systems. There are many countries who have the multi-hazard early warning systems, but early warning is not available for all. So there is a target fixed by World Meteorological Organizations that we should have early warning for each and every human being by 2025. So when you go for these multi-hazard early warning systems, you need disaster risk knowledge. That means you have to consider the past data, find out the vulnerability, find out the climatology, and hence evaluate the risk. You need the preparedness and response capability of the people, the stakeholders, and the disaster managers. Also, you need the detection, observation, monitoring, analysis, and forecasting technique of the hazards. Finally, we should have the technology for warning dissemination and communication so that each and every human being can respond to the actions needed for management of the multi-hazards. So what I want to say that this multi-hazard early warning system will not only help in hazard monitoring assessment, also it can help in providing technical support for vulnerability analysis and risk assessment, for preparedness and planning, for management of natural resources from disasters like agriculture, water resources, energy resources, etc. So this is the status of global coverage of early warning. What I want to say, if you just look at Asia, you will find that there are varied projections. You can say that in comparison to Africa, compared to Pacific, South America, then Asia, Europe, and global, you'll find that there are various capabilities in different countries and different regions. So there is therefore this scope, therefore, to improve the early warning so that each and every person in the region gets the information in time to safeguard his life and property. So what, in the nutshell, if you just look at that, what you find that about 49% say that they have the multi-hazard early warning system. And 28% say that they do not have, and 23% say that we don't know. There is no data is available whether it is there or whether it is not there. Now I'll come a little more specific, how to go for this weather and climate informations, generations and dissemination to general public. If I just look at, there are basically the 6 pillars of weather and climate services. The first pillar comes with observations and monitoring of weather and climate. The second one is the numerical modeling. Third one is the weather forecasting or climate forecasting. Fourth one is the severe weather warning. And fifth one is the sectoral applications for management of various natural resources and to safeguard our life and property. And the last one is the research and development. To carry out all these 5 pillars, research and development becomes the background pillars. So with these 6 pillars, worldwide, people try to go for improving the weather and climate services. So why is it important? Apart from saving our life and property, there could be the quantum jump in economy with the utilization of weather and climate services. The meteorological observations and forecast can be utilized optimally for operation of weather and climate sensitive activities. Many countries have their vision that no weather hazard should go undetected and unpredicted so that you can take action for any particular hazard. Accurate warnings against the hazards with reasonable lead time, triggering response from disaster managers and public can save life and property. If we can have optimum utilization of weather and climate information, we can manage our natural resources in a sustainable manner and hence the sustainable development. Now, if you just go for forecasting, you will find that people have tried to have a very systematic, seamless weather forecasting strategy. There has been attempts, several attempts worldwide to improve the forecast on all spatial scales and also all time scales. People try to provide a very short range forecast called as the nowcast at the location specific level. Then also people try to give a very short range forecast say up to 1 to 3 days in a region specific level, say like a district or a particular meteorological subdivisions. Then also people try to provide the forecast in medium range, that is 4 to 7 days, and then extended range, that is weeks together, that is 1 to 4 weeks, and long range, that is months to seasons. So to carry out all these things, there are various types of models and tools utilized globally. I've just given an example here for India Meteorological Department. We have the Namcast models, which have the resolution of 2 kilometers and forecast up to 12 hours. Then over the regional models, with a resolution of 1 to 4 kilometers to provide forecast at district level or block level up to 3 days. Over the global models, with a resolution of 9 to 12 kilometers, to 2 different frameworks, so like graded framework and spectral framework. Over the global models with the ensemble schemes, with a resolution of 12 to 25 kilometers, and seasonal forecasts with statistical approaches, dynamical global modeling, and dynamical statistical modeling. So while carrying all these things, you need a high performance computing systems, because the science of meteorology is defined as a nonlinear science. And in a nonlinear science, whatever mathematical equations define the physical and chemical processes cannot be solved directly. And you have to go for some kind of nonlinear solutions, which in mathematics we call the numerical mathematics. So therefore, the models which are used for atmospheric predictions are called as the numerical weather prediction models. And these numerical weather prediction models are based on certain approaches which are inherent to have some kind of approximations. Therefore, there will be certainly some kind of error in the numerical model solutions and hence in the forecast. But however, over the years, the performance of the numerical models has improved in terms of their resolutions, in terms of their data assimilation, in terms of their physical processes representations, and hence the processing. And by the way, it has helped to improve the weather and climate services. It is possible by augmenting all the Earth system components into one unified models. There has been national and international collaborations among the practitioners, within the country and outside. There are standard processes defined to carry out all these predictions utilizing the tools and techniques. So I'll just come up from the beginning, that is nowcasting. As all of us know that World Meteorological Organization is the body which provides the guidelines for weather and climate services in the international level. Now, nowcasting is defined as a process where detailed description of the current weather along with the forecast is obtained by extrapolation for a period of about 0 to 6 hours. And usually people provide the forecast up to 3 hours. So in this time frame, it is possible to forecast small features such as the individual storms, thunderstorms with reasonable accuracy. Now, it is mainly due to the fact that the lead time of the forecast increases, the forecast accuracy gradually decreases. Hence, the accuracy of the nowcasting, if we compare, is quite high because you are just providing the forecast as of now. So, for the small scale severe weather event like thunderstorms, hailstorms, squalls, gustiness, etc., nowcasting is the most advantageous tool which is utilized worldwide to provide the forecast. Now, next to nowcasting is the short range forecast, that is 1 to 3 days, and medium range forecast 4 to 10 days. The short and medium range forecasts are also very sensitive to the initial state of the atmosphere, as telling, because the models begin their prediction from the computations. So, meteorology, it is called the initial value problem. If you can detect the initial status of Earth system, then you will be better positioned to provide the forecast for weather and climate. So therefore, people globally try to have as much as possible high quality data collected in different parts of the globe. And all these data are digitized, and these data are assimilated in numerical models so that model can simulate a very realistic atmosphere. If it can do so, then it can predict, it is assumed that it can predict the future atmospheric system and hence the future weather. So therefore, what people do worldwide, people try to digitize the observational data in a standard format so this data can be exchanged among the various users and also the modelers. The high performance computing system is used to run the global models for medium range and regional and mesoscale models for short range predictions. Now, after that, people try for extended range forecast, that is 10 to 20 days forecast, sometimes up to 1 month also. Here, what happens actually, the dynamical forecast skills for intra-seasonal predictions like 10 to 20 days are low. The present strategy to address this problem is through extended range forecast. The extended forecast is the intermediate between the short to medium range forecast and the seasonal forecast. It is neither in weather scale nor in climate scale. It utilizes both in weather and climate scale and tries to provide the forecast. Therefore, what I want to say that extended range forecast is most difficult one as compared to short to medium range forecast and the seasonal forecast. But however, this extended range forecast is very helpful for certain sectors like agriculture and food security, where active break cycle or the hot spells and cold spells over different regions can help a lot to general people and also specifically the farmers and various stakeholders. Similarly, for water, heavy rainfall forecasting river basins, etc., are very much essential in the extended range forecast. Energy, like say power sector, renewable energy, like solar energy or wind energy, also have the high stake if you can provide the particular extended range forecast up to 2 weeks or so. Disaster risk reduction also nowadays, so for example, prediction of cyclogenesis is carried out in extended range forecast so that it can have the larger, longer period for the disaster managers to mitigate the risk. Human health, for example, vector-borne diseases like malaria or dengue also can be provided some guidance in the extended range. So now coming to long range forecast, it is now universally accepted that we cannot predict the climate in the scale of month to season without considering the interaction between atmosphere, ocean, or further I could say atmosphere, ocean, and the land. So with this assumption, people worldwide have tried to develop the coupled models. With the coupled models, we can have the prediction of the season or a month. But however, this is a complex exercise and need multi-institutional initiative and international cooperation. There are many understandings within the WMO framework, and people try to provide the seasonal forecast. This is an example I've just put up here, the probabilistic forecast for rainfall during January 2023 and probabilistic forecast for minimum temperature during January 2023. This type of forecast has been developed utilizing the multi-model ensemble scheme. The 5 best models we take care in the climate scale, climate forecast system scale, and we go for a statistical robust process and provide the forecast for every month and every season. So therefore, it is a possibility at present with the development of the science and technology with respect to climate modeling apart from the weather modeling. So this is another example of how we go for the monsoon forecast for the country and also for South Asia. This forecast, whatever I showed you for temperature, rainfall, etc., are provided for the entire South Asia under the Regional Climate Center of India Meteorological Department and South Asia Climate Outlook Forum. Now coming to specifically the day-to-day weather forecasting and multi-hazard early warning systems, as I told you, it is an initial value problem. So first and foremost target becomes the collection of observations. The observations collected in 4 dimensions, utilizing the surface, upper air, and space-based networks. Now all these observations are utilized to define the initial condition of the atmosphere, ocean, and earth. And by that way, the forecaster identifies the weather systems, and that is the first ground truth. At the same time, all these observations are digitized and they are integrated into an array of numerical weather prediction models. It may be deterministic global models, or it may be ensemble prediction models, it may be regional model, or it may be some kind of special model, like tropical cyclones, or for polar regions, or for fog, or for thunderstorms, etc. Now, all these model outputs are post-processed and provided to the forecaster. Now, the forecaster is equipped with 2 types of information. One is the information on the observations. Other one is the information based on the forecast generated by the numerical models, an array of numerical models. Now, the forecaster has to take a decision. The forecaster goes for a decision making utilizing a decision support system. So a decision support system is nothing but a computational platform, or you can say digital platform, which may be WebGIS platform, where he can compare, comprehend, and analyze the various types of observations and numerical model output, and hence can take a decision. While doing so, it is just like a medical practitioner. A weather forecaster is very much analogous to a medicine specialist. A medicine specialist just like examines all diagnostic tools And finally, he applies the experience, expertise, and knowledge base to write the prescription. Similarly, here, a forecaster utilizes all these observation and numerical guidance and applies his knowledge, experience, expertise to prepare the forecast. But while doing so, if you depend upon one forecast, his knowledge base will be limited. Therefore, what we do actually gradually worldwide, all them interact with each other, and hence they prepare the forecast as a consensus. So therefore, I'll tell the final forecast which is generated, it is an objective consensus derived from a numerical model, array of numerical models, and which is modulated by the subjective consensus derived by the exchange of knowledge, experience, and expertise of the forecasters. And finally, when the forecast is generated, that is the digital one, and that digital forecast is converted into a language form or in a public language that is called the end forecast. So therefore, end forecast is a forecast which is easily understood, which is easily triggered, or which is easily actionable by the general public and disaster managers. And it also includes nowadays the impact information and the actions to be taken by the various stakeholders. And finally, it goes to decision maker, and decision maker takes action. So therefore, if I tell forecasting process of weather, it starts with the monitoring, analysis, detection, modeling, then decision-making process of forecast and warning. Then forecast warning products generation, presentation, and disseminations. Then verification of the forecast. Then documentation of the forecasting process. Then survey, feedback through users' interactions. Now let's look at what are the observational systems which are utilized for the weather forecasting. There are various types of observations. You have the surface observations, upper air observations, marine observations, aircraft observations, satellite observations, and radar observations. So all these observations are categorized in three groups, or two groups you can say. One is the conventional observations, which are taken every 3 hours. There are certain non-conventional observations which are taken at any time, like satellite observations or radar observations can be taken at any time. So all these observations are utilized by the forecasters to identify the weather systems, and these observations are assimilated in the numerical observation models. Little going further, I would say that there are the various types of instruments which are utilized for observations, like for atmospheric process, we have got the barometer, barosuites, and barographs, etc. Now, we have digital barometers. Now we have come up with the wind observations. We have the wind band, we have anemometer, we have high speed recorders, with temperature similarly, starting with thermometer. We have got thermographs, etc. Also the thermistors. You have got the humidity similarly, you have got the hygrometer and hygristors. For precipitation, you have got the rain gauge, you have got automated rain gauges, and you have got self-recording rain gauges. Then you have got the sunshine recorders for sunshine deviations. Similarly for clouds, you have got the ceilometers and etc. And little sophisticated instruments of satellites and radars. And this is the radar picture of tropical cyclones. And radar is nothing but radio detection and ranging. And this radar is utilized for monitoring weather hazards. If radar can detect clouds, radar can find out rainfall, radar can find wind, radar can detect the weather systems like thunderstorms and cyclones. Radar also helps to have the physical understanding of the atmospheric processes. It helps in development of climatology. If I can have continuous observation radar, I can develop the climatology of thunderstorms. It helps in hazard mapping in different areas. It helps in nowcasting. As I told a little earlier, nowcast is nothing but the extrapolation of observations that we utilize the radar information, we can predict about the occurrence of thunderstorms in a particular area. Also, radar data is assimilated in numerical representation models to improve the weather forecasting. Similarly, if I just look at the satellite era started in 1960 with April 1960 with GIRA satellite. After that, we came up with 1974 geostationary satellite, and gradually that expansion occurred. In 1983, Indian national satellite came off. And nowadays, you will find that there is an array of satellites, there is a coordinated group of meteorological satellites, there is the exchange of satellite data among the countries, and you'll find that satellite is being used for monitoring weather hazards, for physical understanding, for development of climatology, hazard mapping, and also satellite data is the major source for numerical weather prediction models. It is more than 70% data which is being assimilated in Android models. But I will tell you, even then, it is only 5% data collected by the satellite. 95% data collected by satellite is not being present. So there is still scope to improve the satellite data in numerical models and hence forecast. Satellite is used for nowcasting to climate modeling. Everywhere you can find out things of satellite data. And it is improved that 25 to 30% improvement in numerical prediction model is possible by the satellite observations. These are the various types of weather systems which are monitored with the satellite. You can monitor lightning, you can draw thunderstorms, and you can have monsoons, we can have the cyclones, etc., with the help of the satellites. Also, if you just look at the forecasting methods, in the beginning, when we started the observation, people thought that we can just utilize these observations to understand, and hence we can predict. So that was the beginning of the synoptic method of forecasting. That means take the observations, analyze the characteristics, evolution of the weather systems, and hence provide the forecast. Next came with the accumulation of data. People came with the synoptic climatology, then the statistical methods like regressions, etc., correlations, regressions to provide the forecast. And finally, people understood that it is not possible to have a realistic forecast utilizing statistical method or the synoptic methods. We should understand the dynamics of atmosphere and hence the edge of numerical weather prediction models. And while doing numerical weather prediction modeling, first we start with a single columnar atmosphere, then 2-dimensional, 3-dimensional, now 4-dimensional atmosphere. And finally, also people thought that direct model output cannot be utilized for forecasting. We have to utilize certain statistical post-processing. Therefore, the dynamical statistical methods came up for weather forecasting. Now, if we just look at the synoptic method, what we do actually in synoptic method, we go for collection of observations over the entire globe simultaneously. Therefore, the name is synoptic. Synoptic means simultaneous observations. Why did it happen like that? Because at that time, there was no camera or there was no satellite which can help to scan the entire Earth. People thought if you can take the observation at a fixed time throughout the globe, then of course we can have the status of atmosphere at a particular time. So therefore people defined the Greenwich Mean Time or universal time coordinate, and the information was synoptic, and meteorology was called as synoptic meteorology. Then people thought that there is a lot of information in a particular fixed time. When we take observations, there are about 30-40 informations. How to utilize that? Now people are talking about Google codes or coding. At that time also people thought of coding, and people prepared the coded message to represent all these observations taken at a fixed time. That is the coded message. Then people thought of exchanging. When it started to prepare the first map of weather informations, it took about 6 months. And telecommunication method also took a lot of time. So therefore, the people define the various exchange of code messages methodology so that the information can go to analysis and forecasting centers. And after that, again, decoding of the message is essential. That was taken up, and plotting of the information were taken up in a chart form. Nowadays, it's automated. And then analysis of charts are carried out and to determine the synoptic weather systems. So what happened actually? When you determine synoptic weather systems, we also consider the characteristics like genesis, growth, evolution, decay, movement, etc. So past knowledge, experience of the forecaster, synoptic climatology based on past years of observations were held in synoptic meteorology or synoptic method of weather forecasting. So this provides a forecast of broad characteristics of a short period. You cannot utilize synoptic meteorology to provide a forecast of 5 days. It can be utilized to provide a forecast for 24 hours maximum. So it is a subjective method. It depends upon knowledge of forecaster. A synoptician is very much similar to a medicine specialist. Now next came the statistical method. We came up with the past data of long period as a time series of data. And using the time series of data, we defined the predictors and predictors. And accordingly, correlations, regressions were carried out, mathematical relationships were established, and all these relations were utilized to provide the forecast. Not very fast actually. A few years back, IMD was also utilizing a statistical method for long-range forecast of monsoon rainfall. But nowadays, we are utilizing the dynamical statistical methods. People also understand the relationship between predictors and predictant by the statistical analysis. It is a good method. It can be utilized an objective method, but however, it is good to predict the mean state, not the extremes. Empirical methods cannot predict the extreme values. Therefore, this is the limitation of statistical methods. Now, let us go for numerical weather prediction methods. In 1904, actually, Judkins first realized the problem of forecasting weather is an initial value problem. In 1920, Richardson attempted to solve the governing equations for predicting pressure tendency. So by that way, gradually people thought that we should understand the dynamics of the atmosphere, and hence we can predict atmosphere more correctly. But however, this approach failed, which could be attributed to unfiltered input data. In 1950, however, Newman, the Fort, and Charney, they came together, and first operational entropy model for prediction of geopotential height at 500 HP was established. And afterwards, entropy need not look back. And now you know, without entropy models, the prediction cannot be done. Now, what you do actually in end-loop methods, actually it is a basic realization that whether any place at any time is dependent, rather a function of 7 basic meteorological variables. 3 components of wind, that is zonal wind and meridional wind, and then you've got the vertical winds. Then you've got the pressure, temperature, density, and humidity. So if at a given time, at a place, value of the 7 variables are known, then it is possible to get the weather at that time at that place by setting up a relation between them and the concerned weather. Thus, the problem of forecasting weather can be translated to a problem of forecasting the future values of the 7 variables. This was the basic assumption. With that assumption, the people went on to define various stages of numerical modeling. Like the input means the observational data, then observational data are coded or pre-processed, then models are run with the computing system, then output is generated, that's model output, that goes to pre-processing and the process goes on. Then from that, we get the post-processed data, and from post-processed data, we go for the forecast. Now, at present, if you just look at, there has been an enormous effort globally to improve the numerical modeling systems. And as I was telling you, without numerical modeling system, nowadays it's not possible to provide the forecast. And there are various types of numerical models. One is the nowcast models, as I told you, a few hours forecast can be given. You've got regional models, which can provide you forecast up to 3 days. Then you've got global models, which will forecast up to 5 to 7 days. Then you've got the ensemble prediction models, which also can provide forecast up to 5 to 7 days, or even 10 days nowadays. And we also have the multimodal ensemble scheme. In this diagram, I'll just request all of you, please look at this diagram. What do you find? Nowcast starts 0 hour up to 24 hours, etc. But as you go, the accuracy level decreases. Therefore, it is called in nature, triangle in nature. The regional model, if you just look at it, does not start at 0 hours, up to 3 hours at least. But I want to say that the regional model cannot be utilized to provide forecast for initial 3 to 6 hours because of certain problems in the modeling system itself and limitations of the models. Similar to global models, just go for up to 12 hours, forecast accuracy global model may not be good. And beyond that, forecast accuracy increases around 48 hours, forecast accuracy maximum for the global model. And thereafter, again, it gradually decreases. If I consider a multi-model ensemble or single model ensembles or grand global ensembles, I find that up to 24 hours, it has no accuracy. And accuracy gradually increases as you go towards the 5th day. So therefore, you have to utilize all scales of models to have a combination of all of them and to take a consensus forecast for its space and time scale. Now, if you just look at, for example, where you stand in South Asia, you will find that we are not far behind from any developed country. This is a comparison between USA models and the models in India with respect to operational modeling system. You will find that our model with respect to resolutions, with data assimilations, with respect to post-processing or pre-processing are almost at par with all these leading centers. So this is just an example. You can just imagine how the modeling system in the country has improved, in the South Asia has improved, and it is helping the country. This is an example of cyclone Fani, which crossed near Puri in Odisha state of east coast of India. And this is the global forecasting system of India Meteorological Department. But however, the models differ from each other. We do not depend on one model. We go for the multimodal ensemble, and hence to minimize the biases among the models. There are a lot of models. You can find the left-hand side. About 10 numerical regression models are utilized in this region to provide guidance to South Asia and individual countries. Now, the next concept comes that instead of utilizing the deterministic model, we should go for the ensemble prediction systems. And nowadays, we provide the probabilistic forecast. The ensemble prediction system helps in providing the probabilistic forecast. So this is a group of or sample of ensembles which is developed by perturbing the initial condition of the deterministic model. These ensemble prediction systems are preferred because the forecast accuracy of ensemble prediction system is better than the deterministic models. So what we do actually, we perturb the initial conditions and generate number of forecasts. For example, in ECMWF model, they perturb 50 times and there are 51 forecasts thus. In our GFS model, we perturb 20 times and hence there are 21 forecasts. So with the help of this 21 forecast, we can find out not only the occurrence of rainfall, for example, also we can find out what is the probability of occurrence of rainfall. When a point comes, how to utilize these NLP models? The NLP models will differ, just like doctors differ, models also differ from each other. So how to utilize these NLP models? In the forecasters, so what we do actually, we compare the initial status of each and every model with the initial status of atmosphere based on the actual observations. And we find out which is the best initial condition among various models. If the initial condition is good for a particular model, we can assume that that model can provide the better forecast, because we have the basic assumption that meteorology is an initial value problem. So next step comes that we can go for the historical performance. I can think about, for example, model X is performing better in the particular season or past 5 years. So I will go for the prediction by that particular model. So that model, if it is not in agreement with the initial condition of today, the initial condition of that model can be improved, and hence we can go for forecast by that model. There can be another approach. Instead of going for seasonal performance as a historical assessment, we can go for performance past 1 or 2 days. If a model is performed past 3 days, it is performing better, I can assume that today also it will perform better. So by that way, that model can be selected. As forecasters of many countries, what do? Actually, they do not believe either historical model or the individual model. They can go for the multimodal ensemble, or you can give more weightage to the historical model, or you can give the more weightage to the model which has performed better in the past 1 or 2 days. By that way, we can utilize the multimodal ensemble to generate a consensus forecast. While doing all these things, the outliers among the different models can be removed, and hence the better consensus can be generated. So like that, we can have a consensus from the multimodal ensemble. We can also examine the ensemble prediction system for each and every model, or grand global ensemble. Finally, we can have the forecast and also the probability of occurrence and probability of intensity of that particular weather parameters. So what to do then? So go with some kind of consensus, either simple or weighted consensus among various models. That is MME-based reliable models with past performance, or subjective consensus by comparing the forecast of different models or comparison and comprehensions. Outliers should be removed, and we should consider the ensemble prediction system along with the multimodal ensembles and also grand global ensemble. By that way, we can have a consensus which is objective in nature. At the same time, also we should utilize the subjective consensus from the experience, knowledge, and expertise, and finalize the forecast. Okay. So while doing all these things, you should have a geospatial platform. You do not have geospatial platform, you cannot compare so specifically. The granular information cannot be generated. So geospatial technology has come up handy in the recent years for improving the analysis, comparison, and comprehension of various observations and forecast guidance, and hence to develop the consensus forecast. So if you go for the decision-making process, therefore, first and foremost, that you should define the initial value problem very correctly, initial status of the atmosphere very correctly. So therefore, you should have the knowledge to identify the errors in the observations. If there is errors in observation, that should be neglected, and hence the correction can be made in your initial assessment of the weather systems. Then you can have the comparison with the diagnosis by the various models, the diagnosed conditions over the area of responsibility along the boundary also. Because if you are giving the forecast, for example, for Kathmandu, you cannot be blind to the area only Kathmandu. You have to take care of Pakistan, Afghanistan, Iran, if you are going to predict weather over Kathmandu in the next 5 days. So for example, in the winter season. Similarly, in the monsoon season, you have to take into consideration the weather conditions in Bay of Bengal, in Bangladesh, and other parts of Nepal and India, if you want to predict weather over Kathmandu. So by that way, you have to consider not only, even if you are going to forecast locally, you have to look at globally. When I have a broad vision globally and go for forecast locally, then forecasters should utilize the appropriate tools. If you are giving the nowcasting, you should use the tool of nowcasting. If you are giving forecast for medium range, utilize the tools for medium range. You cannot utilize medium range tools for nowcasting or nowcast tools for medium range. Then you should correctly use the subjective, the synoptic methods and analytical statistical guidance. They should follow the SOP, manuals, checklists, and roadmaps. The forecaster should focus on the area of most significant weather fast, and should commence the forecast to predicting the evolution and motion of the weather system. The forecaster does not go to predict rainfall fast. Forecaster predicts the atmospheric system, then predicts the rainfall or temperatures. And there should be continuous exchange of knowledge, experience, and expertise among the forecasters so that it is a mix of objective consensus and subjective consensus. So with this, I will now move to the second part, that we have gone far ahead globally and also in South Asia, that instead of giving the simple weather forecast nowadays, it is being the impact-based weather forecast for the region. That means we are now telling what the weather will do tomorrow instead of telling simply what the weather will be tomorrow. So that means we are expected damages and suggested actions are being also provided instead of providing only information which are meteorological in nature. Now, while doing this, what we do actually, we convert, we convert this weather information, or we can translate the weather information into hazard information. Now, after converting the hazard information, it is converted into impact estimation. Once you convert impact estimation, then you generate the response scenarios. Just like, for example, there is a cyclone, that is weather information you generated. Then hazard information is generated, whether it cause floods, whether it cause storm tide, or whether it cause the winds, that is the flooding, etc. That is the hazard translation. Then you come for the impact estimation. What is the impact? If there is a wind of 34 knots, whether it will lead to damage to thatched houses, or damage to pakka houses, concrete houses, or damage to asbestos houses. That is the impact estimation. Then response, what action should be taken? Whether response force should move, whether people should be evacuated, whether fishermen should not go into sea. All the response scenarios has to be generated based on the weather extreme, its translation to hazard, then impact estimations. So to begin with, worldwide people started with just the color codes, and these color codes are based on two factors. One is the impact of the weather hazard, other one is the likelihood of occurrence of that weather hazard. And different categories like very low possibility, medium possibility, and high possibility. And according to the scale of 1 to 10, it was defined. And accordingly, green, yellow, orange, red color codes were utilized. And in this region also many countries are utilizing that. So for green means there is no severe weather expected. Yellow means be aware, there is some kind of severe weather expected. And orange means be prepared for the severe weather. And red means take action without delay. So this was the process started. But gradually, the impact forecast is also matured in the globe. And nowadays, you can find out impact forecast utilizing the meteorological hazards, the secondary hazards, the information geospatial technology, like say digital elevations or digital surface modeling. And also you have got the topography, land use, land cover data, and also socioeconomic database, like the drainage system, populations, or the infrastructures, etc. All these are utilized in geospatial database to generate an impact-based forecast. So this is just an example of impact-based forecast in India in different color codes in a multi-hazard platform. What I want to say that when a forecast is utilizing the forecast, he feels that my weather information is quite high. But when it goes to a disaster manager, he feels that it is nothing. So disaster managers and the weather forecast have to work together. These meteorologists has to be smart enough to mix these two informations and hence to generate the impact-based forecast. When these two green waves and the orange waves will mix with each other, will make a rectangle, the impact-based forecast will be highly successful. And there's geospatial information. So all the information should be in geospatial platform so that each and every person can identify. The information can be personalized for his village or her town, and therefore it can be utilized in a better manner to minimize loss of lives and properties. Now I'll just take some examples. I have just completed the discussion. Quickly, I'll just go through some example. For example, cyclone. An example. What we do actually, we provide the forecast. Based on forecast, we generate the bulletins, and all the bulletins are communicated to general public, disaster managers, and various stakeholders. And these are some of the examples. I will not discuss much. I want to say that the second part of the forecast is the communication to the people. The communication should be in such a way that people can take action. It should be weather information, it should be the climate information, it should be hazard information, then vulnerability, risk, so that people can take action to minimize loss of lives and properties. You'll be happy to know that in Southeastern region, cyclone forecasting has improved a lot, and our forecast accuracy is at par or better than many leading centers. And at present, if you just look at it is not simply the cyclone forecast. There are many forecasts which improve in this region. This is one of the region. This is one of the forecasts. This is marine weather forecast which is helping South Asia. You can find out all graphics information, QGIS and GIS and textual bulletins being provided for the entire region with respect to the marine weather community, for naval, for the sea area, for coastal area, for fishermen, and for ports, etc. And also it is going to the global maritime distress safety system. Now, similarly, there has been a lot of development in South Asia also with respect to flood hazards, and there is a very good understanding between hydrologists and meteorologists. In many countries, the meteorological agency and hydrology agency are one, and some countries also are different from each other. There is a standardized SOP among the meteorological agency and hydrological agency for monitoring of floods and its forecasting. Floods occurs in different ways. One is the riverine flooding, and other one is the flash flooding. For flash flooding in South Asia, we have come up with a South Asia flash flood guidance system, which provides the flood threat and flood potential at each watershed. And watershed size is about 4 kilometers into 4 kilometers. We also come up with the location-specific forecast for urban areas, where you can find out each ward in the particular municipal corporation to have the flood depth and hence the flood risk. And you'll be happy to know that the heavy rainfall warning is improving globally and also in this region. This is just an example of heavy rainfall warning issued by India in monsoon season. It is also improving. And now the forecast accuracy is about 79% in 2022. As I was telling that nowadays thunderstorm is also a killer. The thunderstorm forecast accuracy is also improving. At present, the probability detection is about 80%, 24 hours ahead. And thunderstorm forecast needs very specific information at each individual stations. And it cannot be provided on a large scale because lightning may occur in one village and the next village may not have the lightning. So here also there is a lot of mesoscale modeling. So starting with Professor Mohanty and many distinguished participants here, Professor Dasa. So there is a lot of mesoscale modeling in this region. And also global scale modeling. Now, India is one of the countries or is in this region which is providing the lightning forecast among the 5 countries in the world. So we have got the capability to provide lightning warning, therefore, based on the numerical modeling. Now, similarly, if you look at the heat wave, South Asia also experiences heat wave. If you just remember last year that occurred in Pakistan and India, the month of March, April, May. So we have come a long way. Heat wave forecast accuracy is 90%, and heat wave forecast is possible with the numerical modeling system. And also any forecast, whether it is cyclone forecast or heat wave forecast or thunderstorm forecast, you need some kind of synergy among the disaster managers and the stakeholders as well as the service providers. Now this is the urban meteorological services. Yes, you need to improve the urban meteorological services, and also we try towards that to have information specific to urban area. This is an example of Delhi, and you will find that it provides current weather information, air quality information, radar information, numerical model-based information, and information based on nowcasting, short to medium range forecasting. And also the forecast accuracy is improving like any other part of the globe. Here also the forecast accuracy is improving. So each and every service, whether it is urban meteorology or it is heat wave or cold wave, is challenging. And you need specific information for each and every specific sectors. So this is agriculture. So this is another success story. We have come up a long way to provide the agricultural information to the farmers. And the farmers, it has improved that they can improve their economy with the forecast specific to the agriculture. Similarly, aviations, nowadays with the improvement in socioeconomic conditions, more and more people are traveling, and hence the number of airports are also increasing. In aviation also, there are very specific forecasts generated by the NMHS. We have issued a meta, specific rain forecast, local forecast, area forecast, airfield warning, route forecast, takeoff and landing forecast, and SIGMAT. Yes, all these forecasts are being generated by the National Meteorological Hydrological Services and is helping in safe aviation processes. With all these type of services being provided globally, every NMHS tries to improve the warning dissemination. And redundancy is maintained in warning dissemination. People try to provide the information by landline. Also, people try to provide the information by space-based communications. Especially when you consider South Asia, we have got the land-based, landlocked regions like the Himalayas. We have got the oceanic areas where it is very difficult to reach out to the last mile. Therefore, the space-based communication also has played a role. At the same time, the social media like say, Facebook, Twitter, Instagram, blogs, etc., YouTube are being utilized, and communication has been enhanced with the last mile with the help of this ICT. Also, come up with APIs. The informations are being generated in an automatic program interface so that it can be utilized digitally by any user If they have a decision support system, they can utilize our informations. And in this fora, I will take the advantage, request all the students and all the practitioners that IMD is willing to provide free of cost data if it is utilized for research purpose, for development of the tools and technology. We can have a collaboration and you can utilize all data. People talk about big data. IMD has a big data source and you can have all these informations. Towards the conclusion, I just to say something about the climate monitoring. Climate monitoring is very much essential to detect the climate change, to attribute the causes towards the climate change, and also to project the climate changes. Not only that, the information on climate can be utilized in various sectors, as I have discussed a little earlier. You can find out the graded climate data for the region, and it can be utilized for various purposes. The climate can be utilized for long-term planning. Climate can be utilized for extreme events. The climate can be utilized for managing the natural resources. So there are many applications. Just I have discussed the hydrometeorological applications, for example, drought management, for sectoral applications like health, energy, and other sectors. But there is scope. I will request all of you to visit the India Meteorology Department website in Pune. There are a lot of informations for South Asia, which can be utilized by all of you for your understanding, research, and development of application tools for climate. So this is for climate forecasting. We also provide the climate forecast for South Asia, and South Asia climate forecast is not only limited to only rainfall and temperature, but also the physical processes like prediction of El Nino and La Nina, prediction of Indian Ocean dipole, also available for this region and globally. And we are a part of the global community, and we are recognized here as Regional Climate Center. So therefore, there is scope, there is data to work together. The scientists, engineers, and the practitioners, the students can participate locally and globally for benefit of the South Asia with this huge amount of data available for research purpose. So this is another example of climate publication. A lot of publications are available and digital publications are there. You can utilize for this region. Now, climate data, you can find out the climate data service portal. It is online portal, and also you have a data supply portal where people can take the data online. You need not apply physically for the supported data. So, but still there are certain challenges with respect to weather and climate services. I will say that there is still need for upgrading the forecasting capabilities in the region with the modernization or upgradation of forecasting centers and modernization and upgradation of the observational tools and the modeling and entire value chain like observations, modeling, forecasting, severe weather warning, sectoral applications also needs continuous expansion and upgradations. We have to upgrade the obsolete components so that we are utilizing the latest tools and technologies. We have to improve the public weather service, especially the communications. The communication does not mean the wired or wireless communications. Communication means the way in which you communicate to the people, your language, your expression, the mode like audio, video, etc. The scaling of a forecast is also essential in public weather services and early warning in terms of the lead period, in terms of the quality, and also in terms of the quantity. Also, you have to develop the user-oriented sector applications. Now, the number of sectors are increasing, and there is still scope, therefore, to develop user-oriented sector applications. There could be the startup groups. We also encourage the startup groups. Those are interested to take off the study, to develop some kind of technology on their own. We'll be happy to coordinate and collaborate with them. Now, so all these things are being taken off, and especially I'm talking about the impact-based forecast and risk-based warning systems, where you need the climatological hazard information, exposure, and potential impacts. All this has to be integrated, and there is a scope for the NMHS to work. And this is a very nascent science now, where we are moving from what the weather will be to what the weather will do tomorrow. And for this purpose, the new technology like AI/ML or the big data concept can be utilized along with the numerical modeling. We believe in the principle of the dual engine. The NMHS can work on dual engine concept so that data can be converted to value, and hence we can have more and more realistic, useful information on weather and climate, which can be utilized by the society to safeguard the loss of lives and properties, and to minimize loss of life and properties, and also to improve the economic conditions. So thank you very much.
Thank you very much, sir, for your wonderful lecture. Now we have some time for taking up the questions from the participants. So I think I request the session moderators question and answers sessions moderators to take up the questions to the panelists. Thank you. Dr. Rohini or Dr. Mohan?
Yeah, okay. So, sir, thank you very much for this nice lecture. Regarding the data, there is an immediate question from anonymous person. I would like to ask if the IMD data is not restricted to India alone.
Excuse me?
I would like to ask if the IMD data is not restricted to India alone.
Yeah, it is not restricted to India alone. Anyone can take the data.
Another question from Thurakai Well. Which data set is best for weather forecasting? What is accuracy range?
Yeah, there are various types of data which are utilized in numerical weather prediction models. There has been some kind of forecast sensitivity experiments. So what we found that that observations taken with the radio sun and radio winds, that is very important, which provides the vertical profile of temperature and moisture and winds. So these informations are very useful for improving the forecast. But at the same time, the satellite-based, for example, water vapor from GNSS, and there are many such tools which are also helping to improve the forecast. And I will tell you this composition or the contribution of various types of observational sources to the forecast is not uniform in all scales. The forecast for particular hazards may be dominated by certain kind of informations. The forecast for another hazard may be dominated by some other informations. So for example, if your cyclone is over the sea, in the deep sea, the satellite becomes the most important data. The same cyclone, when it comes to nearby the coast, radar becomes the most important data. And when it is crossing the coast, the ground truth becomes the most important data. So that it is a relative term, but however, there has been sensitivity experiments and it has been established in general. If you just look at the RSRW informations collected through the ascents by the balloons along with the sensors are very crucial and followed by certain satellite observations. And specifically the data which can provide you the vertical profile of temperature, humidity, winds, etc. are most important.
Okay. Sir, another question from Shivang Dorji. What has been done to address transboundary air pollution in India and its neighborhood?
Yeah, there has been a lot of work with respect to air pollution. Say, air is being polluted globally. It is not restricted to India alone or with respect to South Asia alone. But at the same time, I will tell you that we have got the capacity to monitor the air pollution. There has been a good network, enhancement of network to find out the concentration of various pollutants, including say PM10 or PM2.5, and to identify the various sources also. Inventory has been generated in certain areas also, but you have to go a long way to develop very specific high resolution inventory of the sources of data. The second one is that we have also gone for a very digital platform-based air quality monitoring system. And we have also come up with air quality modeling. Nowadays in the country, we have got a number of models to monitor and predict the air quality. And specifically for the cities like Delhi, we have got the specific modeling system to provide the forecast of air quality. Not only that, there is an institutional mechanism which takes care of the coordination, exchange of information and collaboration among the various stakeholders, and hence finally to provide the guidelines to the public for management.
Sir, another question by Swadhin Satapati. There has been an increase in the localized precipitation events, which is specific to a very small spatial scale that used to be widespread in the past. What could be the reason behind this?
Yeah, study says that due to the impact of the climate change, the heavy rainfall events, the localized heavy rainfall events are increasing in tropical regions. It is not limited to South Asia. I'm talking about the entire tropical region. That is also found in South Asia. Here also, there is increase in frequency of heavy rainfall events, roughly 15 centimeters more in 24 hours. That increases there. And it has improved also. It can be attributed to increase in global warming or the impact of the climate change. There is another category of localized heavy weather events that is called as cloudburst. The cloudburst occurs in hilly regions like say, northern India, Nepal, Bhutan, some northern parts of Bangladesh, and Pakistan, Afghanistan. Now, these cloudbursts are defined as the event when the rainfall amount is 10 centimeters more in 1 hour. It is found that there is no such change in the frequency of such cloudburst events in this region. But if you consider the micro cloudburst, that means cloudburst with the amount of rainfall is 5 centimeters in 24 hours, it shows that yes, there is increase in frequency of this mini cloudburst with rainfall amount of 5 centimeters and more in certain areas.
Another question by Patita Kalyana Sahu. Why there is westerly jet occur in the winter season and easterly jet in the summer season? Although their altitude is same, but why their location is different on Indian subcontinent?
Yeah, this is the climate. Actually, if you just look at how the jet develops, actually. If you are a student of atmospheric science, then you can understand. The jet stream develops because of the thermal wind. That's difference of winds, difference of temperatures. Okay. So if you just look at in the winter, you have got, say, let us take Delhi and Moscow. The temperature difference between Delhi and Moscow. You will find how much the difference. It will be that is sub-zero temperature. Sometimes it may go to minus 20 degrees Celsius in Moscow, and here will temperature around say 25 degrees Celsius or 20 degrees Celsius in a particular day, today, for example. Okay. So by that way, you have got a large temperature gradient, and this temperature gradient leads to the development of the jet streams. And the subtropical jet stream therefore occurs with more intensity in the winter season and roughly runs along say 23 to 25 or 30 degree latitude. But in case of the monsoon season, you have a tropical easterly jet, and tropical easterly jet is one of the components of the monsoons, and that develops in a tropical belt. So you can say near about 5 to 10 degree or 5 to 15 degree latitude longitude. The entire genesis is completely different. It is in association with the various types of circulation features occurring in that particular region. If you remember, you've got the two types of circulation. One is Walker circulation, and there is the Hartley circulations, and all these lead to various types of developments.
Sir, another question by Prashant. Sir, any suggestion on hybrid forecasting, a combination of dynamical model and statistical method like AI/ML for better region-specific prediction? Yeah,
I agree. That was my last slide, that we have to go for a dual engineering concept. You cannot neglect the numerical weather prediction modeling. It has to continue because numerical weather prediction provides you the science. It is based on pure science. It is the dynamics of the atmosphere, ocean, and combination of them. It has to grow. It will grow in future, and it will help you to identify the various physical processes and chemical processes, and also it will help to improve the weather forecasting. But at the same time, the numerical modeling system requires a lot of computing power, a lot of observational data, and those observational data has to be assimilated, model has to be run, and forecast to be generated, and that generation of forecast takes sometimes time, say 8 to 10 hours. Then models become late. At the same time, if you go for the numerical analysis with the help of this AML technique, the generation of forecast can be instantaneous because it will not take much time to develop forecast running the AML model. So what people are trying at present, that two systems, one is the numerical modeling system, other one is the AML, they should complement with each other. For example, I will tell you, there can be, one of the slides I have shown you, the forecast can be generated for the nowcast purpose from 3 to 6 hours. But after 3 hours, the numerical regression model cannot provide you the nowcast. It has the limitations. But forecast up to 3 hours can be generated with the help of the AML. This is number one. Similarly, the pre-processing of the data in numerical modeling can be carried out with the AML. The post-processing of the data can be carried out with the help of the AML. So there is no confrontation between numerical modeling and the AML. They have to support each other or complement each other.
Dr. Mohan, would you like to go ahead with the questions?
Thank you, Dr. Rohini, and thank you, respected sir. So, sir, actually, I combined two questions together. One is the related to the ensemble forecasting, or if a single forecast model, which model is the best prediction model for the weather hazards, or if we use, so how many numerical model we need to together for the ensemble forecasting? And second part is the sir, machine learning and artificial intelligence, how it could be perfectly provide the forecast of natural weather extremes. Sir, please.
Yeah, fine. So thank you. So I will respond to the second question because I was responding AML in the previous question. This AML technique also can be utilized for downscaling. So you have got a forecast by the numerical model with a resolution of say 12 kilometers. Or the regional model, you've got, for example, 3 kilometers. But there is a demand that you should have village level forecast. So downscaling of the forecast, utilizing the past data from deep learning can be carried out with the utilization of AML from the output of numerical prediction models. So therefore, there is enough scope. Number one is that you can go for pre-processing. Number two is that you can go for post-processing development of the forecast products. Number three is that you can develop the sectoral application products utilizing AML. Number four is that the products can be downscaled as per the required spatial and temporal resolutions utilizing AML from the basic global models or regional models. The next point is that we have got a number of models, for example. Say, we have got 10 models for cyclogenesis or the cyclone tracks. And these tracks will differ from each other. And there could be a number of ensemble products also. You have got single model ensemble, you have got multi-model ensemble, you have got also the grand global ensembles. There can be 200 tracks, 2000 tracks sometimes generated by the Monte Carlo simulations. So how to take a decision then? The AML can be utilized to find out the best one. And hence, it can also help in the extreme weather, like say cyclogenesis, cyclone track, cyclone intensity, etc. Similarly, for the extreme weather, like rainfall events or heat waves or cold waves, etc. Now, the first question I'll come, how to utilize, how many models we should. So I have explained in my talk that how to utilize the numerical regression models. So the process is that we have to go for the best model, and no model can be best every time. The model run in the 0 UTC may differ from the model run at 12 UTC. So there will be model run variations from one run to other one. And also there will be variation from one model to other model. So what to do then? We have to find out some kind of historically best model or best 1 model, 2 model, 3 model, 5 models, etc. So for example, for tropical cyclone forecasting and rainfall forecasting in India, we utilize 5 best models. Okay. So depending upon the computing power, depending upon your analysis, you can also decide which models you should consider and how many models you should consider. AML also can play a role in that. And also there are many other ways like tensor components and other analysis also you can decide which model should be considered based on the past performance. The key is the best performance based on the history. And from that, we can decide the best models. For long range forecast also, multi-model ensemble, what we utilize nowadays for last 2 years, we utilize the 5 best models. So that is, you can say a decision which can be quantitative, utilizing the technology like statistical analysis or AML, whatever it is, or otherwise depending upon your experience, etc., as you do not have the tools, if you do not have the tools. But I will tell you, as a forecaster, while going for the predictions, the ensemble forecasting is preferred as compared to deterministic model. Because ensemble forecasting provides you the probabilistic forecast, number one. Number two is that the accuracy of the forecast is also higher. It is proved, number one. Number two, if you ask me whether I should utilize multi-model ensemble or single model, I will tell it is a multi-model ensemble. The objective consensus developed by multi-model ensemble has the better accuracy than any individual model.
Actually, there are lots of questions, but we have to make some limit. So one last combination of questions is whether don't maintain any political boundary. So regional cooperation is very much needed. So when any extreme hazards occur over ocean regions or in the land boundary, so how regional country to country coordinated data or coordinated tools like radar or satellite, these kinds of data sharing and provide the preparing a good forecasting is possible. So what initiative need to be taken? Sir, please.
Yeah, thank you very much, actually. In that sense, South Asia has come up a long way. There is a very good cooperation among the countries in South Asia, and also it is extended to Southeast Asia and that is the South China Sea region. We have got an RSMC here in Delhi, that RSMC for tropical cyclone purpose, the information is provided to all the countries in this region, also to Southeast Asia, Middle East, etc. Also, we got RSMC for severe weather information. We provide forecast for heavy rainfall, winds, storm surges on day-to-day basis, valid for next 5 days. It is provided to all the countries in South Asia. It is starting with Myanmar, Thailand, and here Pakistan, Afghanistan, Nepal, Bhutan, Sri Lanka, Maldives, and India. And as you told, from one region to other region, yes, there is a need for some kind of seamless data flow. For satellites, there is a coordinated group of meteorological satellites defined by World Meteorological Organization. Under that forum, data are exchanged. We have the access to foreign satellites. Those foreign satellites data are available in RSMC website. One can visit and they can utilize those informations. It is available in geospatial platform also, our satellite data. We have developed some kind of a rapid system, which is also geospatial in nature. You can identify your area. There you can find out convective clouds, and you can find out lightning. All information also you can find out. The next is the radar. There is no exchange of radar data at present. Of course, radar image is available in certain countries. And the point is that we do not have also sufficient radar in this region. There is a need for augmentation of radar network. But the process is on in RA2 region to exchange the radar informations among the countries, to develop a platform like satellite where all radar's images will be available so that a mosaic can be generated. It can be utilized by all countries, especially for nowcasting of the severe weather events. For numerical modeling, yes, certainly the global models which are prepared by India Meteorology Department, it covers the entire region, South Asia, Southeast Asia, Middle East, and also entire oceanic region. And specific products have been generated from South Asian countries. We have prepared specific products, meteograms, whatever is needed. Whenever request comes, we prepare meteograms. Under the RIME schemes also, we are preparing all digital data to all countries so that they can utilize this data in their decision platforms. We are also willing to help for our handholding for any kind of development with respect to numerical modeling and post-processing, and also the impact-based forecasting. We also conduct the capacity building training programs. So any suggestion, if it comes for, we can organize those capacity building programs.
Thank you, Dr. Mohan and Dr. Rohini, for efficiently handling the taking the nice questions from the Q&A box. And now, before going to say vote of thanks, so I request all the panelists to turn on their video so that we can have a photograph. Mohan, you also take. I am also taking.
Yes, please. I am taking also.
Yeah. Yeah, fine. Thank you. Now I request, I think we have come to the end of the session for today's lecture, second lecture. So I request Dr. Mohan Kumar Das to propose vote of thanks for today's lecture. Over to you, Mohan.
Thank you, Dr. Lakshmi Kumarji. So I hope you can see my slide, right? Yes,
Yes.
Okay. Good afternoon, everyone. I believe it is a great honor and privilege for me to present the vote of thanks for today's International Lecture Series session. So on behalf of all the participants and from the SAMA, I am glad to be here to express my vote of thanks in these sessions. First and foremost, I would like to heartfully thank our today's research persons, Dr. Mohapatra sir, Director General of Meteorology, India Meteorological Department, for being here with us and for his excellent delivery. We are listening to your speech with keen interest and believe all other participants did the same and enjoyed it most. I am confident and hopeful enough that your sharing of knowledge, experience, and views with us on weather and climate services gave us a new ideas for thinking and challenges and would encourage us to work in this sector in future. Our heartfelt gratitude goes to respected member of the Coordination Committee of SAMA Training Course, especially warmest thanks to Professor Air Vice Marshal retired Dr. Odityagi sir. He is the president of SAMA. Professor Dr. Someshwar Das sir, secretary of SAMA. Professor Dr. Dotla Venkata Bhaskar Rao, PDRA at JS University. Dr. T.B. Lakshmi Kumar, he is the session moderator from SRM IDST. Dr. Rohini Bhawat, she is from SPPU India. Dr. Ranjit Kumar Singha, Dr. Shagata Parya, he is the treasurer and he is from BIT Mestra. Dr. Madan Sidgal from Tribhuvan University, Kathmandu, Nepal, Board of Governors, Organizing Committee for arranging such an effective, excellent training program. I believe this program has become a fruitful and supportive one in changing the knowledge, skills, and attitude of the participants to a better level. Finally, I'd like to thank all the members, live members, research members, student members of SAMA, and all other participants from home and abroad for their spontaneous interaction and for making the program lively and enjoyable and memorable. Thank you all once again for being here with us. Thank you, sir. Thank you all.
Thank you, Dr. Mohan, for presenting the vote of thanks. So with this, I think we have come to end of the session. So I would like to mention that next week, same time, we will be meeting for the third lecture. The lecture will be on research and scope of weather and atmospheric sciences. The lecture will be delivered by Professor S.K. Dash. So he is from IIT Delhi. So I request all the participants to attend that lecture 3. And we will be sending this the YouTube link and other details of this lecture by email to all of you, and the Zoom links for the next week also will be sent on the next Friday. So I request everyone to please attend the lecture 3 without fail. So thank you very much. Once again, we thank you very much for your valuable time. And I also thank all the panelists and
Lakshmi,
sir.
Yeah, are we able to keep track of these questions, because we are not able to reply to all?
Yes, sir. Yes, sir. Yes, sir. We have noted down all the questions. I think Rohit is doing it. Yes, sir. Yes, sir.
Yeah, maybe that some of those questions can be clubbed, and 8-10 questions which have not been answered can be answered by some of us, or we may request even Dr. Mohapatra to answer, and then we can put it on a website or can communicate to those people. It will be good.
Sir. Sure, sir. We will do it. Yes, sir.
Thank you so much to each and every one of you to have made this second lecture also equally successful. And let's look forward for the third one. And we keep following, like you did for this lecture, continuous communication to all the participants registered and others also, so that we maintain tempo. Today, I think we had some 350 marks reached. So it's okay. I think it is we have to keep this momentum going.
Less than the last week though, but it is okay. Last week it was 398. So maybe because of the festival effect, more people from India, so probably they have not attended because of the festival. But hopefully, yeah.
Right. Okay.
Thank you very much, sir. I hope we can close the session. Thank you very much.
Yes. Thank you. Bye.
Thank you. Thank you all participants. Thank you very much for your time. Thank you very much. So I found from Q&A session that some of you have missed in entering the attendance. So now I have posted the attendance link. I request please fill the attendance sheet. I have just posted in the copied in the chat box. So I will wait for some more time. So I think you kindly fill the attendance sheet. So I saw one question that where I can get WRF training, model training. So I could not find his name. So you can write an email to SAMA. In SAMA also is having some plans to provide training for WRF model. And if you can send an email to SAMA-03, I'm just writing the email here. So if you can send an email to this, if you can write an email to this address, I think we will tell you, I think where the training will be given. I hope, but of course, but you need to contact them, and you have to get the training. So we will be compiling all your questions. Probably we will come with responses for these questions to you. So thank you very much. I am closing the session. Thank you very much. Thank you once again for your time. Thank you. We'll meet next week. Thank you very much.